We're going to talk about a little bit of new technology as for concern to the Indian market. It's relatively new for us. We're going to talk about is corrugated beam solution. It's corrugated wave as a sinusoidal technology, as a sine beam technology. So basically system is corrugated wave eye sections, is customized system where it's a flat flanges and the waves are corrugated as a sinusoidal forms. The most critical part when you are kind of enhancing it to sinusoidal system to the waves, it's kind of helping it to strengthen the buckling of the waves. And it helps to economize the design of the flexure members to the tune of 30% when as far as we are talking about the hot roll sections, and in range of 10 to 30% when we are talking about the PEB sections. So of course, we're going to talk in more details about all that information. It's basically the waves are in kind of sinusoidal formation. It's around 2 to 3 millimeter thickness of the wave, which is a normal way. It can go even up to the 6 millimeter. It can be a customized solutions. It's very easy, very simple. It's a completely factory-made system as kind of the automated robotic system, which has very high rate of the production. And it could be very easy and simple construction at the site. And of course, it has kind of very different way of the final product looks like with the waves in the waves. So it's aesthetically much pleasing solution as in with the PEB system. So, yeah, there are international standards like the American standards, European standards, which already takes care of the design of this kind of the sinusoidal wave solutions, and those can be adhered very well for the design of the structures. Always in Indian conditions or always in the market is always kitna chalti hai. So about the cost part is one of the major aspect about with this solution. Of course, we already know the PEB or the welded eye sections are much economical compared to the hot roll sections. But on top of it, when we have this sinusoidal beam solution, we can further economize the section requirement. All the sections are the custom designs. The flange design requirement of the flanges, the thickness of flanges, the width of flanges, also the wave requirement also are always custom designed to the specific project requirement. So it just as much economized sections could be very easily possible using the sine system. You can easily go around 40 meter spans without any supports, and we have depth of around 1.5 meter as the sine beam. Even you can go a depth of 1.8 meter and you can bridge around 55 to 60 meters of the hall size without any additional support requirement. So you can really go long spans. And as we talked about, it is, yes, material saving, direct material saving is one of the aspect, but with the higher stiffness, with the depth of the beams, your stiffness of the building is much better, and that performance under the lateral conditions is much improved with the sine system. Fewer secondary benefits like the handling requirement is much lower also, it's just much easier for the execution at the site. And of course, the production system, as you see on the right side, this picture elaborates its complete robotic system to produce the sine beam. So it's a really highly productive and very high production capacity of the systems. These are the details about the sine beams. The widths of the sine beams are normally ranging for the flanges as 160 to 450 millimeter. The thickness of flanges ranges from 80 to 30 millimeter as custom design as you require for a particular building. The depth of the beams ranges from 300 millimeter to 1.5. Thickness can go 2 millimeter to 6 millimeter. Normally 2 to 3 millimeter is the standard waves. If you require something special, you can go even the higher thicknesses of the wave as well. Here are the good details. It's not exactly the sine form, it's just always a curvature in the sine form, perfect curve. In actual practical way, it's two curvature as the valley and peak are curved, and in between portion is the straight is what the automated manufacturing system. We can also make as a tapered sections depending upon your design requirement. Normally we go for the parallel flange system for the scene system, but even if you are looking for something too as a tapered system, that can also well done using the sine system. So tapering of section, normally a parallel flange with the wave thickness 2 to 6 millimeter. If you're looking for top flange and bottom flange to be a variable size, that can be very well done. If you're looking for tapered section using the same size of the top and bottom flange is possible. And even if you're looking for the top and bottom flange variable, along with the variable thickness as a tapered section, all kind of customization is very well possible with the sign beam system. The design ideology, this is kind of the most primitive details, very basic information. It's designed like a truss arrangement. So it's a top and bottom flanges, which takes care of your moments, and the wave part, which is the sinusoidal system, take care of the shear forces. So, which is normally what do as a truss design system. Of course, there is American standards, AISC, also European standard, which gives very elaborate details about the design calculation to be done using the sinusoidal sections. This is one of the Indian considerations what we have done project comparison as what we can do as the design along with Alimatic, our technical partners. We have designed this building. This has been approved by IIT as well for the design consideration. All loading consideration like the gravity loads, wind loads, seismic conditions. This is for our own plant at Angul, so that's designed for seismic zone 3 of India. And it's been designed, verified by IIT as well, an approved system. So this hall is 2 halls of 24 meters by 104 meters. And it is having the overhead cranes of 20 metric ton capacity. On every columns, we have considered the 1 ton capacity of the jeeps to be attached to the structural system. So what we have here is the primary scene columns and the secondary scene columns above the gantry level. We have reduced the column sizes. The roof rafters are complete scene parallel flange system. Bracings in plan and also a vertical bracing system, and along with the tie beams at the different levels as required for the stability point of view. There is an overall stability. This is the primary member sizes. Secondary members like the connectors, the purlins, and those details are not compared here. Right now is a primary structural system and saving of 15% what we have observed for our own building as what we are designing. So with this, I give kind of few of the references that what we are doing. This is the factory building, what we are with the sign beam. This is exactly what would be replicated at our factory at Angul. These are for the hangars, where we can also have the tapered columns and the parallel flange roof system. Here is the production facility when you are looking for the large span in both direction. The scene beam solution can also with the primary and the secondary roofing solution can well be done. Here is the good example. It's around 55 meter spans of these sections, and you can still achieve. This is 1.6 meter deep sign beam section. Both direction purlin also, if you are looking for large span using the primary and secondary solution with the sign beams. Even if you are looking for the heavy load arrangement, this kind of very heavy plant. So the columns which are having very heavy load capacity, those are converted into the braced column system. And of course, this can be very well using the composite system also. Column can still be a concrete column, and the roofing or the beam solution can be a sign beam. So a composite solution is well possible. So this kind of very brief, quickly details about the scene system.